Hello everyone, welcome to my channel GVS Chem. In this module, let us discuss the states of matter, the subtopic gas laws. The gas laws topic is very important in the point of board examinations and entrance examinations, JEE and NEET. Please subscribe my channel, like, share and comment my videos. Measurable properties of gases are mass, volume, pressure and temperature. Measurable properties of gases are mass, volume, pressure and temperature. Now let us find the relation among these measurable properties. So relations among mass, volume, pressure and temperature. The relations among these measurable properties are dealt by gas laws. So what are the gas laws? Gas laws are Boyle's law. Boyle's law deals the relation between pressure and volume at temperature constant. And Charles' law deals the relation between temperature and volume at pressure constant. LUSSACS law deals the relation between pressure and temperature at constant volume. And Avogadro'S law deals the relation between volume and number of moles. Now let us discuss about each of these gas laws in detail. So the first one is Boyle's law. Boyle's law states that the volume of certain mass of a gas is inversely proportional to the pressure applied. The relation can be shown mathematically as volume is directly proportional to 1 by P, or V equal to K into 1 by P. K is the proportionality constant, and this proportionality constant depends upon the units of volume and pressure used here. Therefore, PV equal to K. Suppose if pressure is P1, then volume is P2. Volume is V2. If pressure changes to pressure increases to, if pressure is P1, then volume is V1. If pressure increases to P2, then volume decreases to V2. Thus P1 V1 equal to P2 V2. So this is Boyle's law. So Boyle's law can be stated in other way also. The product of pressure and volume of certain mass of a gas is constant at fixed temperature. Now let us discuss the different graphs. So graphs of Boyle's law. How do we draw the graphs for Boyle's law? This is a P. P is taken an x-axis in terms of a bar, and here this is V in decimeter cube. So if we draw a graph between pressure and volume of a gas, the graph comes in this manner. Right. Now, if we take a different graph, this is a pressure axis, pressure in bar, and this is a PV, the product of pressure and volume. So the graph between pressure and PV. So if we draw a graph between pressure and product of PV, it comes in this manner. So the graph is the graph of P versus PV is a straight line parallel to pressure axis, So here this is at a temperature T1. Suppose if we increase the temperature, say at a temperature T2 which is higher than T1, this is the temperature T2, and the graph is obtained. The graph obtained at the temperature T2 is above the graph drawn at T1. Therefore, at any temperature, the graph between pressure and PV is a straight line parallel to pressure axis. The graphs are plots drawn. The graphs are plots drawn between pressure and volume are called isotherms. Now, if we draw another graph, so this is pressure here, pressure in bar, and this is reciprocal of volume in decimeter. So the graphs come as a straight line from origin. So this is one graph. This graph is at T1 temperature. If we increase the temperature and draw another graph, the graph comes in this manner, T2, and this is T3, etc. So these are different types of graphs. The graph between pressure and reciprocal of volume. Suppose if we draw another graph for the same gas, graph between pressure versus volume at different temperatures. Pressure versus volume at different temperatures. So the graphs are drawn in this manner. This is at 150 K. This is 323 K. This is 600 K. So as the temperature goes on increasing, the graph between, this is a pressure in bar, and of course this is volume in decimeter cube. So as the temperature increases, the graph between pressure and volume, the curve decreases. The curve of the graph decreases. Right. Now let us see the applications of Boyle's law. Applications of Boyle's law. When a given mass of a gas is compressed, the same number of molecules occupy the smaller space. That is, density of the gas increases. Density of the gas, therefore, at higher pressure, density decreases. Now, during the atmosphere, at atmospheric pressure, how atmospheric pressure changes? Atmospheric pressure at sea level. Sea level is more. Why it is more? See, we know that air has layers. Air has layers. So the upper layers exert force on lower layers. Therefore, at sea level, the pressure, atmospheric pressure is more. Whereas as we are going to higher altitudes, the density decreases. That is, pressure decreases. So pressure increases at higher levels, higher altitudes, pressure decreases. Right. Now not only that, the Boyle's law can be used in case of cycle pumps, inflating the tires, etc. Pressure gauzes and others. Now let us see the relation between. Now let us discuss the Charles law. Charles law states that the volume of a certain mass of a gas is directly proportional to the temperature provided the pressure is kept constant. So Charles law states that the volume of certain mass of a gas is directly proportional to the temperature provided the pressure is kept constant. Therefore, volume is directly proportional to T. P is constant. Now, V is equal to K into T, where K is the proportionality constant. Right. Now, if V1 is the volume at temperature T1, then if temperature is increased to T2, then volume increases to V2. Therefore, V1 is equal to K1T, V2 is equal to K2T2. Therefore, here this can be written as V1 by T1 is equal to K or K1, V2 by T2 is equal to constant. See here, the proportionality constant depends upon the units of volume used and of course temperature. Therefore, V1 by T1 is equal to V2 by T2. Now if we draw a graph between volume and temperature, it is drawn in this manner. So this is volume, this is temperature in degree centigrade, volume in decimeter. So at a definite pressure, if we draw a graph, the graph comes in this manner. So this is 0 degree centigrade, 100, 200, 300, etc. Now at 0 degree centigrade, it meets the volume axis at this point. Now if we extrapolate the graph, means extend the graph. So if we extrapolate the graph comes in this manner. The dotted lines indicates the extension of the graph, and the graph extended meets the temperature axis at minus 273.15 degrees centigrade. So this minus 273.15 degrees centigrade is the temperature at which all gases are assumed to occupy zero volume. So at minus 273.15 degrees centigrade is the temperature at which all the gases are assumed to occupy zero volume. That means hypothetically all gases are assumed to occupy zero volume, but strictly speaking, gas means matter. Matter is that anything which has mass and occupies volume. So if the gas occupies zero volume, means there is no matter, so which is not possible. Now taking this zero, taking minus 273.15 degrees centigrade as initial temperature, a scale was introduced by a scientist known as Kelvin, and hence this scale of temperature is known as a Kelvin scale. Kelvin scale or absolute scale. Absolute scale. Absolute scale means it starts with absolute zero. Absolute zero means minus 273.15 degrees centigrade. So absolute zero is equal to minus 273.15 K. So at absolute zero, every gas is hypothetically assumed to occupy zero volume. Now we can define Charles' law in a different way also using Kelvin scale. Therefore, the volume of a gas, volume of certain mass of a gas, volume of certain mass of a gas is directly proportional to Kelvin temperature. Kelvin temperature or temperature in Kelvin scale. Kelvin temperature, provided pressure is kept constant. Pressure is kept constant. Therefore, V1 by T1 is equal to V2 by T2. So if we draw graphs between, this is the temperature in Kelvin scale, whereas volume in decimeter cube. So if we draw graphs, the graphs come in this manner. This is graph at P1 degrees, P1 pressure, that means at 1 pressure. This is another graph at P2, this is another graph at P3 pressure. So these are joined in this manner. Graphs between temperature and volume. The graphs drawn between temperature and volume are called isobars. Just now we discussed about the absolute scale, absolute zero, absolute scale or Kelvin scale. And of course, absolute zero is minus 273.15 degrees centigrade. How we got this? Experimentally, it was found that for every 1 degree centigrade rise in temperature, 1 degree centigrade rise in temperature, volume increases by 1 by 273.15 part of original volume. That means if volume of gas at 0 degree centigrade is say V0, then volume at 1 degree centigrade, how do we get? See, whatever be the volume at 0 degree centigrade, for 1 degree centigrade we get an additional amount of 1 by 273.15 part of the original volume. That means V 1 degree centigrade, this is the volume at 1 degree centigrade, V 1 degree centigrade equal to V0 plus V0 by 273.15. This is the volume at 1 degree centigrade. So this is equal to V0 into 1 plus 1 by 273.15. So similarly, we can get volume at T degree centigrade is equal to V0 into 1 plus 1 by 273, this is T degrees, 273.15. As temperature goes on increasing, volume also increases. Similarly, if we decrease the temperature, so if temperature decreases at minus T degree centigrade, then V minus T degree centigrade. This is the volume of the gas at minus T degree centigrade equal to V0 into 1 minus. As volume is increasing, we took plus. As volume is decreasing, here decreases. So minus T degree centigrade by 273.15. So in this way, finally what happens, it is found that at minus 273.15 degrees centigrade, all the gases are assumed to occupy zero volume. The next law is Gay-Lussac's law. Gay-Lussac's law. Gay-Lussac's law gives the relation between pressure of a gas and temperature. Pressure of a gas and temperature. So the statement can be made as the pressure of certain mass of a gas. So pressure of certain mass of a gas is directly proportional to absolute temperature. Directly proportional to absolute temperature. Therefore, mathematically we can write pressure is directly proportional to temperature, or P is equal to K into T. K is the proportionality constant. If P1 is the pressure at T1 temperature, if pressure increases to P2, then if temperature increases to P2, then pressure increases to P2. Therefore, P1 by T1 is equal to P2 by T2. So this is a Gay-Lussac's law, which gives the relation between pressure and temperature. Now the next one is Avogadro'S law. Avogadro'S law gives the relation between volume and amount of the gas. Volume and amount of the gas. So the law states that equal volumes of all gases, under similar conditions of temperature and pressure have equal number of molecules. Therefore, V is directly proportional to N, where V is the volume of the gas and N is the number of molecules. We know that number of molecules are proportional to number of moles. This is N, capital N. So V is directly proportional to N. Number of molecules directly proportional to number of moles. Therefore, instead of a capital N, we can keep here a small n. So number of moles is represented by small n. V is directly proportional to N. Or V is equal to K into N. If small m is the mass of the gas, small m is the mass of the gas, and capital M is the molar mass of the gas. Small m is the mass of the gas and capital M is the molar mass of the gas. Therefore, number of moles equal to m by small m by capital M. Or see here, previously we have V is equal to K into N, where N is the number of moles. Therefore, V equal to K into mass of the gas by molar mass, K into small m by cap M. Now here in Gay-Lussac's law, we can draw the graphs between pressure and temperature. So here this is temperature in Kelvin scale, pressure in bar. Therefore, the graphs come in this manner. This is the graph at V1 volume. So if we extrapolate in this manner, they meet absolute zero at this. And of course, this is the graph at V2 volume. This is the graph at V3 volume. So these graphs we call as graphs between pressure and temperature are called isometrics. In the next module, let us learn to derive the gas equation, and based on gas equation and other gas laws, let us do some numericals. Please subscribe my channel, like, share and comment my videos. Thank you.